Everybody to track two, day two of the Plone conference. We are getting started here with Philip's talks on growing pains. Philip, I'll let you take it away.
Hey, thank you for having me, and it's a pleasure to be at this amazing online Plone conference. I want to talk to you about growing pains. I'm not talking about myself, even though I might have experienced those many years ago. This is about the issues that you face when your project grows in all kinds of ways. For example, the code base grows, the database grows, and the problems grow with that. Let's start. I'll cover a couple of symptoms, I guess 6 altogether, and I'll try to discuss some of the remedies that you might, the causes and some of the remedies that you might use to fix these symptoms or to heal these symptoms. Number one, that is a huge database. So cause number one is obviously, most of you probably guessed that, a huge number of revisions and versions. No, it's not content, it's actually only revisions. And the main remedy for that is to just get rid of them all. The good thing is that most clients, when you ask them, hey, can we upgrade to Plone, whatever, new version, can we also lose all the revisions? After some deliberation, they mostly say yes. And voila, your database shrinks from 80 gigabytes to 10 gigabytes, for example. There is this handy line of these handy lines of code that you can use to just purge the whole history storage. And after you pack your database, all the old versions will be gone. So why is this a good idea? It is a good idea because for various reasons, there can be a lot of revisions of content that actually doesn't exist anymore. There are ways that this just happens during operations. So if you don't want to get rid of all the revisions, you can still clean up your database using Collective Revision Manager, a handy add-on that allows you to inspect the number of revisions per object and in a nice table, and remove revisions or purge all revisions except for the last whatever 1, 2, 3, 4, 5 versions. Also, good idea always is to disable versioning of files. You actually don't have to disable that by default, but if someone has enabled that, that would be a good idea. One client of ours had a cron job running every night, and they imported some files, Excel files, I guess, into the Plone site, and they were wondering why their database was so big. So there was your answer. You can also change the versioning policy to not create a revision on every save. That is usually a good idea to do that. If you already have this problem, you can just switch that policy, and then users have to check a box if they actually want to save their change as a new revision. So you have a couple of revisions only when major changes happen, but you'll have to educate your editors for that. Next cause is obviously you forgot to switch on packing. Just do that. You need to use the ZeoPack script that is part of ZeoServer, and you definitely should add a cron job for it that runs probably not nightly, but weekly is a good idea. Now the one you guessed was the first one, but actually that doesn't make up that many gigabytes in my experience, but there is still huge chances to have a lot of unused content, and obviously you just need to delete it. But the hard thing is to find it first. There is a handy example browser view called Statistics in Collective Migration Helpers that gives you, I don't know, there are 500 events from 2005, 600 events from 2007, and it shows you in which folder the most content is. So you have some pointers at least to go and find and delete them. Looking by hand does not always help because some Smart editors might have disabled inheritance of permissions, and you may not be actually be able to see these. So number 4 is the searchable text index. That can be quite a big object if you have a lot of data that is actually indexed. So one option is to remove the searchable text index, replace it with Solr or an Elasticsearch integration. We often use Collective Solr for that. Actually, I never removed the searchable text index because it was not that big for our cases, but I've heard of cases where that is absolutely helpful. Also, you don't have to index all your files. So if you have these converters for all these file types, then all these file types will also be converted into text. And yeah, probably you don't need all of these. Okay, moving on. You can have large blobs, obviously. If people upload big data, big files, then this will blow up your database. Just an example, Plone.de, a website that the Plone community of Germany set up, had a ISO file for a Plone installation that contained a full Linux. That was pretty big. And another client of us had Windows installation files, also ISO files, just uploaded into their Plone site. That doesn't really make sense, so don't do that. A good idea how to prevent that is to limit the upload size and size of files, and get stats and remove replace too large items if you have the right statistics. Okay, the last but not least is, but that is very rare, are actually aborted uploads, because Plone has a smart logic to keep uploads that you abort in an annotation on the portal. Just check annotation portal file upload map. Okay, try to go a bit faster, because the really interesting things are further in the end. So symptom 2 is a slow site. It happened to me, so maybe it happened to you as well. There can be unneeded full renders of content. The most common cause is to either call an object in Python or call an object in a template, which is much more easy to do, because you just have to say tell define foo context foo when foo is an object, like foo context is a folder and foo is a page in that. This will render the full object and assign that to a variable foo, even though you just want to see if that actually exists or not. So in a path statement, this will be no call column, or even much better, just use Python statements, please. So you make sure that you're not calling foo. Please don't wake up too many objects. This makes your site slow. Always try to use brains and metadata. And the difference is huge, even with dexterity. Listing 3,000 brains in my last project took me 0.2 seconds, and listing 3,000 objects from these brains, waking all of these up, took 2 seconds. And that is not an acceptable operation for one single page load. The same happens in Volto when you use the search endpoint with full objects, because that wakes up these objects. Obviously, most views that are in Plone itself are paginated, so this doesn't happen, or it shouldn't happen unless you write bad code. But still, just use brains. They're so much tastier. The third cause is no caching. I actually wondered why a couple of my client sites were slow, and I realized that for some reason caching was not enabled, because either I forgot it or someone else switched it off or whatever. So just switch in built-in caching. It already gives you bang for $0. If you want more, add varnish. There's really good documentation for that. Manage your CO cache. That is more of a science, so I'm not going to get into that. So how many objects do you have in your database? How many objects do you want in your CO cache? There is a magic number there. Ask in the community forum. And in your methods, use memoize if you have stuff that is called very often by during different requests or during the same request. Speaking of during the same request, no, this is a different cause. Hardware, please, if it's slow, just throw some more hardware at it. That is the obvious, an obvious solution, but mostly the one that doesn't give you a lot of results, even though your consulting time is maybe way more expensive than just buying 8 additional gigabytes of memory. So if you have enough memory to keep your database in RAM, that is a good thing. Now, slow code, that is really tough. But there are nice helpers. Obviously, you need to profile your code. You need to read your code and probably understand what's making it slow. That would be best. But if you don't see it at the first glance or even at the 10th, profiling is your solution. A very handy toy for that is PySpy. You just run it, pass it the PID, the process ID, and you can start it and stop it again. And it even runs in Python 3, but it can even profile a code that is running in Python 2. And it's really handy for if you have one browser view and you're wondering why that takes so long, just start PySpy, render that browser view, and it'll tell you why it's so slow, probably. Also, obviously, don't call multiple methods multiple times from templates. Assign variables instead. You may also have slow data sources. The internet is obviously much slower than your database itself, so you should decouple stuff that is important using Redis or Celery. Your choice of async implementations or something just as basic as lazy loading images, if they are from outside. If they come from Plone, or even speed up your site. Okay, getting fancier, conflict errors. So conflict errors happen when 2 requests work at the same time, and one is changing code, and the other is changes an object, and the other changes the same object but expects the state from the previous situation. So it has changed, and yeah, it is complicated, but it is simple because there is built-in conflict resolution in the ZODB, but I see many build-outs, including ours, bad me, that by default didn't enable that because the ZO server does the conflict resolution, and it needs to have all the application code available to be actually able to do that. Otherwise, your transaction will be aborted and your data will be lost. Yeah, there should be other issues. Yeah, number 2. Another cause for conflict errors can be long-running requests that change data. So you should, everything that takes long would be excellent if it wouldn't write in the database at all. Then you don't have any chance of having a conflict error. If you do something that takes long, you should do intermediate commits. Everything that takes very long is mostly something administrative, like importing data, so it doesn't really hurt if you have intermediate commits. You should prevent crossfire from external data sources, for example, cron jobs, or just switch off editing. Obviously, for normal operations, it's not an option to disable editing. And again, your choice of async operations. Talk to Asko about that, probably. Okay, getting more fancy by the minute. PosKey errors. They're actually really simple. The ones that show up are mostly blob missing errors. I think that's the subclass of that. A blob is missing. Obviously, you forgot to copy all the blobs during some rsync operation. You can use experimental graceful blob missing if you still want to go ahead, and it'll create dummy files for all blobs that is trying to touch. You can also simply write a simple browser view that goes through all the content, checks if there's a file field, tries to access the file, and if there's a blob, if there's an error, it just logs it, and then you can delete it. But yeah, they're not that interesting. There can be cases when you have 2 0 clients and the syncing doesn't work well. That is really tough. Talk to Alessandro about that. And now for the really interesting part. Module not found error, and yeah, everything that comes from that. I could simply read you the whole blog post that I wrote about that, but I only have half an hour left, and that would probably take 1.5 hours, so I'm not going to do that. Instead, yeah, this is boring. This is the interesting one. Sorry, I've had to delete that. Should have deleted that. So the code to unpickle some data is missing in your database. So there are a couple of things that you can do. You can either ignore these errors. That is obviously an option. For example, if the lifespan of the project is not too hard and normal operation just works. Even if packing fails, if your database will be deleted by the end of the year, these few gigabytes in the database will probably be much cheaper than the time you spend removing the broken objects or cleaning them up. So ignoring these errors, as long as the page still works and has a limited lifespan, is totally acceptable. You could, maybe a migration is planned anyway to the new version, and you're planning to do an export-import migration, or you just do a migration in place, which also fixes many of these issues, because you will encounter them then, and the money, the time you spend will be lost in the budget for the migration probably. So this is definitely an option, and I have a couple of sites where I just decided to do that. Option 2 is to fix these issues with a rename dict. I'll show an example for that. Option 3 is to work around with an alias module patch. And option 4 is the most interesting one, actually finding out what is broken, why it is broken, and trying to fix it. So option 2, obviously there's no slide for ignoring, because that I just ignore that slide. So a ZODB update rename dict, what I would call it. Here's an example for that. I think it's stolen from Zest ZODB update, mostly, or from ZOP itself. OFS has a couple of these. This is basically some a entry point in your setup PY, where you map old code location to new code location. And the good thing is the new code location can just be an interface, like in the second, yeah, can I see my mouse? Whatever. In the second thing here, bam, I can't see my mouse, whatever. Yeah, so it will replace every instance of iPersistent extra that was imported from app interfaces with a simple ZOP interface, which basically is nothing, which is not true, but it's not that much. So it will work again. See Zest ZODB update for a couple of examples that are actually really useful. The option 3 is to work around with an alias module patch. Alias module is something David Glick, I think, came up with, pretty nifty. And in your init PY, you can basically patch your Python path so that everything, for example, the interface, the Solr index processor from collective Solr interfaces is no longer throwing an import or module not found error or an attribute error, depends on how it's used, but it'll just be nothing because it's an empty object, it's a BBB object. And the same example with the slideshow descriptor with a simple item. The only important thing, or the important thing, is that you need to use the right alias. It's either an interface, a simple item, or an object. In rare cases, there are more complex things. Check Plone upgrade the module. It has a init file, and it has a ton of these, and they are run every time you start up Plone. Yes. So the important one. So finding out what and where broken objects are, and then fix them. So you should use the ZODB verify to find out everything that is actually broken. pick one at a time. Don't do all of them at the same time. And then use ZODB verify to inspect these one object and find out where it is, and then remove or fix it. And so number one, I'll do a live demo. Yes, I will. So this is a client project. It's an older version of the database, so it still has errors. So what you should use first is use ZODB verify. It's a Python package. You can put it in your build out. You have to use the checkout from the pull request 8. It's still not finished yet. I just don't have time, but it works fine. And run it against your database. I will do that just now. And I pass the database name to that. This will give me, after it scans the database for everything that cannot be unpickled, and it'll log a lot of error messages. And at the end of these error messages, it'll show you a summary showing which errors appear, how often, and for which objects. It'll take another second until it's finished. It should be done anytime now. Yeah, sharing your screen during a presentation takes some, yeah, we're done. Okay, here, this is the final report, ZODB verified done. It's 145,000 objects, 45 of which could not be loaded. And here are the exceptions. And now you need to pick, this is basically the result, pick one of them. And very important, you will forget what you just did because you're excited, well, because you're debugging at the moment. So make notes and write upgrade steps. Don't just hack the fixes away, and store your terminal log in a safe place. I forget what I did all the time. Maybe it's the age, but I'm pretty sure the same happens to you. So pick one of these issues. Let's pick one. Okay, so let's see, 45 is broken. What do we have here? Oh, I know that, 4 digits. Okay, let's check for that, 4 digits. Let's pick one. And what you do now is you ask ZODB verify to please inspect this object. And you should also pass the -D for debug flag. And yeah, just press enter and wait for ZODB verify to do the magic. So now it already it loaded my object. It is obj. It's obviously something in the Plone registry, an integer field. And the interesting thing, and that's the problem with the ZODB, not the problem, it's the architecture, is we don't know the name of that object because well, it's an int object somewhere in the Plone, by the Plone, a class, an instance of Plone registry field int. So we guess it's in the registry, but we don't know where it is used and what's the name as which that it's used for. So we can say continue, and then we get a representation of the pickle, and we can look at that, and this is pretty fancy, but it will give you some hints. For example, we can see, okay, this is from 4 digits portlet Twitter. I've seen that a couple of times because it probably did not uninstall properly in projects. So we look at the first, let's skip ahead 4 here, up. So first you can inspect the object, then you get the error message that you get, which is a module not found error during unpickling. Then you get the pickle. In most cases, some cases, it won't work to display the pickle. And you should find out where that is, which means you should find out where it's actually referenced. And when you press continue, ZODB verify does exactly that. It will create a reference tree to for reverse lookup. It's a huge dictionary, and it will tell you where this object that we're looking for, this Plone registry field int IT, int is referenced. And it tells me, okay, this is referenced by, okay, this is a bucket. And the bucket then is referenced by a tree. And if it has a name, it shows the name as well. And in this case, it doesn't have a name, at least none that it could find. So the tree is referenced by the registry, I guess. And the registry is referenced by is portal registry for the Plone site. So here you see, it even finds out what the name of the object is. Obviously, these have no names that the script could find, but we can see that this is where we're going with this. So now you can decide to do various approaches, but I will do something special. A ZODB verify can be instantiated in various ways. The obvious one is .bin ZODB verify, and you pass it the database, but you can also run it as an instance script. So bin instance ZODB verify, and again the object ID. I need the object ID. Where is my object ID? Here's my object ID and the -d flag. So now the same thing happens as before. Plone is loading, or ZODB verify is loading the object, but in this case, it is loading the object inside a running Plone instance. So I actually have a Plone instance available. So the startup looks a bit different, you might see. And after a while, you will have, yes. So you see the object is as before, and app in the is no longer none, but now is app. So app.plone is my Plone site. Add.plone portal registry is my registry. I could now try to look for these trees, but I know how the registry works. So I'd say, let's assign a variable for the registry, records, let's say, let's inspect that reg, do that I for I in reg records, keys, I'd say if for digits in I. Let's see if that works. Yeah, here we are. So there are obviously settings from that darned portlet that was installed in that page. Let's use that as a variable, records equals, because this is the key and we can access that with the key. So now we can do for record in records, del reg record. I'd say that would work. No. Record in del reg records. Yay. So now I actually deleted these objects, but I'm not interacting with the running request. So there is no transaction. I have to do a transaction myself. Import transaction commit. Oops. And now I can still continue. The ZODB verify script is still running. It will show me the pickle because the objects are still there. I just removed the references to these objects from the records, which is the storage for the records. It's actually underscore records. I think records is just a pointer to that. But still, here's my pickle. It's building a reference tree of the ZODB because I changed something. I did a commit. So now it's a JSON file in your temp folder. So it goes through the whole ZODB and builds this reference tree. And the output now, compare that to what we saw before, is here's what we saw before is now nothing because it's no longer referenced. So what does that mean? That means that after we pack our database, then these objects are actually gone, and we can run ZODB verify. You can now we will still get an error not error message. They will still show up, but I guarantee you, I'm not going to pack the database now, but I will guarantee you that these objects are then will be gone after packing the database. So that is, I guess this concludes my live demo. Let me switch on this again. Yeah, hack it away. That's what I did. Check that it's gone. As I said, the broken object still exists, and the OID should, but the OID should not be referenced anymore. So there are a couple of things that are hard about that. And let me maybe quickly go back to the, I hate that, to this part. It takes some practice to read this properly, but the tip is the first find is usually right. So this, when it tries, ZODB verify tries to go through the database to find references to that, it finds multiple. But the first one is usually the one that is most interesting. Looking them up, because it follows each reference, and there are circular references. So it stops at level 50, I guess. That's what I coded in. And it stops at root objects. So there are a couple of root objects that are referenced, the obviously Zope app and Plone, where it stops and doesn't traverse anymore because Plone is referenced in other places. So you would get lots of circular references. But usually the first one is the most important one. And a lot of things, annotations, int IDs, relations, they are all stored in buckets and B trees, and these usually have no name and are hard to inspect in PDB. That is not very straightforward. So you have to do some educated guessing to find out what it is. But the most common culprits are actually, let me show you. Where do I have that? I had that. Yes. So this is the blog post I was referring to. At the very end, it has lots of important information how to deal with OIDs and stuff like that. But there are the frequent culprits, and the frequent culprits are int IDs and relations. I will have a lightning talk about relations. About, where did I lose that? Here, about relations. And so if you have a migrated database, a lot of these error messages where it says module not found archetypes, products archetypes, or ATC content types are actually relations, and you should get rid of these. It's all documented here, and you can use collective relation helpers to get rid of these. These are, I'd say, 95% of all broken objects. The more important ones are, or more interesting ones are those, the other ones. Okay, last but not least, I still have a couple of minutes left. I'm actually, yeah, I will be done early, is bad code. So I could talk for hours about that, but most of that is so obvious that I don't have to explain anything to you. When a project grows, you will, or when you inherit a project and it had a long lifespan, you will encounter all of these issues, and there is no easy remedy for that except for being really careful when you write code. So when your lifespan is short, you can't just delete all of that, that's fine, but it's terrible to have unreadable code that is written by people who think they are so smart that it has to show in every line. And that is just insulting and bad. And it will bite you or whoever comes after you. And it's really bad practice to write code that is overly complex. If your code is untested, if your code is actually unused, make sure it is used. If it's undocumented, if it's not maintained, for example, if you have a dependency that has is not maintained anymore. I'm not sure if anyone tried to install a collective flow player in the last couple of months. They will probably have encountered the issue that hardcore, I don't know how to pronounce that, is no longer available on GitHub, on Pipey. So it is just, it's a good idea to keep that up to date. Yeah, complicated and unreadable is not completely the same, but very related to each other. Overly complex, obviously also similar, and basically just too much code. Don't write code. If you can convince a client to not want a feature because they will probably only use it once or not use it ever, that is a win. Every line of code that is not written is a good line of code. So with this stupid pun, let me say thank you. Obviously, yes, we are for hire, even though we're really, really busy. And I'm happy to answer a couple of questions that might have been asked already. I have no way of seeing any questions. So Fulvio, if you want, you can read some questions, or should I just move to Jitsi right away? I will just check the Loudswarm platform if there are questions. Oh yeah, there are some. I see them. Okay, Marcus, how to limit the upload size in Plone, not a web server? Yeah, obviously my first answer would be do that in Nginx or Apache. In Plone itself, that's a good question. I know that in archetypes there was a max size equals something for file fields. For dexterity, I'd have to check, but it's probably pretty simple to find out. If you want, I can check. Raphael would like to know if you can find my slides. Yes, I will upload them. I will upload them and put the link in the Slack. I guess there is also some pre-arranged way to link the video and the slides together. So yes, I will upload them. And Paul asked, do you have any good resources to effectively read flame graphs? Yes. I used, God. Okay, let's move to the next question because I have to look up, I wrote down a nice library that visualizes flame graphs, but I forgot how it's called. I'll tell you in the chat later. I'll look that up. But actually, I like I like reading the lines. The lines are absolutely fine because it shows you the Python path to the method that is taking too long, and how long it takes. I'll stop sharing my screen, by the way. This makes no sense to look at Catalina's as nice as it is. It just, it has 4 columns, PySpy by default, and you just click on, I guess you use 3 or 4 in most cases, and shows you which one it is. And from there, you can, in most cases, just estimate and guess what the problem is. Yeah. But profiling is a whole science. There can be a lot more issues. Oh, I see more things. No current transaction TPC abort. Not yet, no. I'm pretty sure, ask in the community forum, there are so many smart people who are, who know they can read pickles in raw, probably. No, I think only Jim Fulton can do that. If all code is in zero, so where do you update to have to stop all sites in this zero? What? I don't get the question. Sorry, I don't understand the question. Well, you manage your Zio clients with whatever you like. I usually use supervisor, and you can stop multiple instances at once if that's the question, but I guess it was not. That was it, I think. Is there another question? Not a question, no. Did I miss any questions? Other than that, it is 15:45. Let's head over to the face-to-face meeting in Jitsi, and I'll talk to you soon. Thank you for having me, and it's a blast being at the conference. Bye-bye. Live long and prosper.
Thank you, Philip. You would never disappoint, unlike me with my moderating skills. But I will stop the stream now.